Let's discuss about West zones of lung. There are 4 West zones in lung. Let's discuss about them. This is right lung. This is left lung, right? So in between we have heart. We have heart. Don't worry about the way I done. I just want to make you understand, okay? This is apex, right? At the apex we have zone 2. We have zone 2. At the base we have zone 3. Zone 3. In between these two we have zone 4. Zone 1 is usually not present in healthy people. They are present in certain pathological conditions, okay? So we have 4 zones. One is not usually present in normal people. They are present in certain pathological conditions. Zone 2 is present at the apex. Zone 3 is present at the base. In between these two we have zone 4. Let's discuss about each one of this, okay? Zone 2 first. We'll discuss about zone 2 first. So this is lung, right? Zone 2 is present at apex. You see, for circulation to reach apex, it has to move against gravity, right? Circulation, it has to reach against gravity. Due to this movement against gravity, there will be drop in pressure. There will be drop in pressure. Let's see how much the pressure drops. Systolic in pulmonary circulation systolic pressure is usually 25 mm of Hg. Systolic pressure in pulmonary circulation is usually 25 mm of Hg. This drops by 15 mm. So the systolic pressure, it becomes 10 mm of Hg. Similarly, diastolic pressure in pulmonary circulation usually is 8. This also drops by 15 mm of Hg. So the diastolic pressure will be minus 7 mm of Hg. So at the apex, the systolic pressure is 10 mm of Hg, diastolic pressure is 7 mm of Hg. Let's see the various pressures at the apex. Systolic pressure is greater than alveolar pressure, greater than diastolic pressure, okay? Diastolic pressure. So systolic pressure is greater than alveolar pressure is greater than diastolic pressure. So see, if the circulation has to go first, if the circulation has to go to apex during systolic pressure must be greater than alveolar pressure. So here we can see systolic pressure is greater than alveolar pressure. So circulation can go to the apex in systole. Circulation will go to the apex because systolic pressure is greater than alveolar pressure. Now let's see how circulation goes during diastole. You see, diastolic pressure is less than alveolar pressure, right? So as the diastolic pressure is less than alveolar pressure, circulation will not reach to the apex during diastole. So during diastole, blood supply will not be there. So what we have to understand here is apex. The apex receives blood supply only during systole. Only during systole. During diastole, there will not be any blood supply. So this circulation is intermittent circulation. Okay, the circulation is intermittent. Intermittent circulation. This is about zone 2. Now let's move to zone 3. So as I told you, the zone 3 is present at the base. Let's see about zone 3. See, circulation moves along with gravity now. In the case of pigs, the circulation moved against gravity, but here the circulation is moving along with gravity. Circulation moves along with gravity, right? So now what happens is there will be increase in pressure. As it is moving along with gravity, there is increase in pressure. Let's see the changes in systolic and diastolic pressures. Systolic pressure in pulmonary circulation is usually 25. Now this will increase. There will be extra 8 mm of Hg added to this 25 mm of Hg, and this results in 33 mm of Hg of systolic pressure. Okay, now let's see diastolic pressure. Diastolic pressure in normal pulmonary circulation is 8. Now 8 mm of Hg will be added to this diastolic pressure due to gravity, and now diastolic pressure it becomes 16 mm of Hg. Let's see the order of various pressures. At the base, the systolic pressure greater than diastolic pressure greater than alveolar pressure. Okay, see, the circulation can reach both in diastolic pressure the circulation can reach to base both in systolic and diastolic phases. So we can say circulation is continuous. Circulation is continuous. Circulation is continuous. So this is due to gravity. When the person comes to supine position, or when the person lies on supine position, this gravity will not act, right? When the person lies in supine position, gravity will not act. So there will be interchange of zone 3 to zone 2 when the person lies on supine position. Okay, remember this. When the person lies on supine position, zone 3 will become zone 2. Okay, this is about zone 3. Now let's discuss about zone 1. As I told you, zone 1 is not present in normal person. This is present in certain pathological conditions. Okay, do not exist in normal person. That is the first point. Do not exist in normal individual. Then when does it is present in the lung? See, in zone 1, if it is present, let's see the pressures. In zone 1, the pressure is alveolar pressure greater than systolic pressure greater than diastolic pressure. See, if you look at the pressures, you can easily analyze that circulation will not happen both in diastolic as well as in systolic. So circulation will not reach to this zone even if it is present in pathological condition. Okay, so there will be no blood supply in zone 1. When do we see it? It is seen in pass-to pressure ventilation. Pass-to pressure ventilation, or when there is decrease in diastolic or systolic pressure. Okay, when there is decrease in diastolic or systolic pressure, the pulmonary pressure, the alveolar pressure will go up, right? When systolic and diastolic pressure comes down, it appears that alveolar pressure is greater. So when the alveolar pressure is more than systolic and diastolic pressure, circulation will not happen. So let's see the conditions where we will see decrease in systolic pressure and diastolic pressure. Usually in shock. This is seen in shock. Okay, here what happens is there will be hypovolemia, right? Due to this hypovolemia, this results in hypotension. Hypotension in the sense there will be decrease in systolic pressures and as well as sometimes even diastolic pressure. Due to this decrease in diastolic pressure and systolic pressure, alveolar pressure appears to be higher than systolic and diastolic pressure. So obviously circulation cannot reach to that site. This is about zone 1. Let's see zone 4. Zone 4. This is present at the base. I told you at the base zone 3 is present, right? Even to the utmost base, this zone 4 will be there, right? This is left lung. So at the base this zone 4 will be present. Here what happens is there will be increase in extra alveolar pressure due to gravity. As it is present at the utmost base, there will be increase in extra alveolar pressure due to gravity. Alveolar pressure due to gravity. As there is increase in extra alveolar pressure, blood will not flow to that compartment, or blood will not flow uh, to that site, or otherwise there will be less blood flow compared to zone 3. Okay, as there is increase in extra alveolar pressure, either blood cannot reach or there will be reduced flow compared to zone 3, compared to zone 3. So this is something about various zones present in lung.